Welcome to the Apigee Up Close webcast. We do these twice a month and the topics change based on demand. Hi, I'm Danekind. I'm an Apigee customer engineer. So for today's agenda, we're going to do a brief overview of API Management and Apigee Edge. Then I'm going to do a demo in Apigee Edge and show you a few things in there, and then I'll take some questions. Let's get started. So let's talk about API Management. Let's consider a scenario. Let's suppose you've got some services over there on the right-hand side. So anything you happen to have around REST services, SOAP services, microservices, maybe it's your service bus, anything over there. We've got some folks over here on the left, partners, employees, customers, and they have applications, and those applications need to get data from these services. There's a need to control what those applications can do and how they can access that data and how frequently and things like that. That's where API Management comes in. That's where Apigee Edge fits in here. So we put Apigee Edge in here to control how those applications can access that right-hand side. Now we also have to think about application developers, the people who write all those applications. How will they gain access to these systems? What do we need to do in order to get them credentials so that Apigee will let them into those back-end services? How will they read documentation? How will they learn how your APIs work? And how will they sign up for access? Along the way, as traffic starts to flow through here, we'd also like to be able to create some reports that tells us about which applications are accessing this, what they're doing, how frequently they're calling, what's the level of traffic, how does it compare to past trends and things like that. So a few more things we might want to do. We could use Apigee in here to build a facade over the backend services. We can present one set of interfaces to those external applications compared to what's inside. We can control access, so different applications might have access to different services, and they might get different things when they call them. We can rate limit to protect those backend services. If one of those applications is calling too quickly, we can shut it down. We could also impose some quotas. Maybe we want to give developers limited access to some of these things, and we may want to charge money for other things. We can add caching in there to improve performance. So if we already have the answer in Apigee Edge, we don't need to call the backend. We could reformat that request as it comes in and make it appropriate for those backend services. The response that comes from the backend services, we could change that around too before we send it back to the applications. We could manage a whole collection of those app developers out there and manage their credentials. And along the way, we could collect usage analytics, and that would give us some insights into how our API program is going. So these are all things you might want to do with an API management platform, and this is a good overview of what API management is. There's a new way to think about the problem of services. Traditionally, we would have thought of this as an exposure problem. So we've got some data, we need to expose it through a service. But there's a better way to think about this, a pattern that we've seen our most successful customers adopt, and that's to think about it from the outside in. Meaning that rather than just thinking about exposing a service, what we're actually thinking about is the end user who will use the application. What's that user's experience? What is it like to use the application that they're using? And how do we empower the developer who writes that application? That comes from having great APIs and building a set of APIs that are very nice to use for that developer. And that's what the API team does. So if we think about this from the outside inward, we'll have much better success. There are a lot of people who use Apigee Edge. What's interesting for me when I look at this slide is I look at all the different businesses that these people are in. What they all have in common is they're seeing success from having an API program, either internal or external. So let's look at Apigee Edge. Apigee Edge is an API management platform, and we can think of it in three major parts. We can think of it as a set of API services. That's the part that routes traffic. That's the thing that we put between the applications and the services. And we can think of some needs in there along the lines of security, transforming messages, acting as an enterprise gateway, orchestrating those back-end services, and preventing people from abusing those services. In terms of developer engagement, we need to have a developer portal, and that's a good place to put documentation and for developers to come who want to consume these APIs and read about how to use them. There's a need to have API products, so a way to take all these services and bundle them together into different packages that provide different access. And there may be a need to monetize services where we're going to charge money for access. Finally, we need a way to measure everything, and that's where API Analytics comes in. We can measure developer engagement, we can measure business metrics, we can look at operational metrics, API program metrics, and we can monitor the platform to see how it's working. So all of this together makes an API management platform. So what's the difference between an API gateway and an API management platform? Well, an API gateway is a small subset of an API management platform. As you can see from this slide, an API management platform does a lot more than you would do with a simple gateway. So a gateway would do basic things like collect security tokens. But there's a lot more to solving the API problem than there is with a simple gateway. So let's talk about some advantages that Apigee has over other solutions in the marketplace. In Gartner's recent Magic Quadrant survey, they found Apigee to be a leader, and they ranked Apigee highest in terms of the ability to execute and the completeness of their vision. You can find more about this on the Apigee website. There are a few different options in terms of how you deploy Apigee. Apigee is offered as a software as a service managed in Google Cloud. You can run it on premises in a data center. You can run it in the cloud of your choice, or you can run hybrid, where most of it runs in the cloud and some of it's going to run near your computing resources. These are all different options for running Apigee Edge. Apigee Edge offers global scale and availability. It's hosted in 13 data centers around the world, and historically we had 99.999% availability. The developer portal within Apigee Edge can be easily customized to meet your needs. If this is an internal portal, you might keep it kind of simple, but if it's external facing, you might want to brand it to match your branding of your website. Apigee gives you a choice between configuration or coding. There's a number of out-of-the-box policies that do basic things. That's what we're seeing on the left here. You can drop in these policies to request an access token or add response caching. If you want to do code-driven development, you can build your own policies and you can drop those in and mix them with the out-of-the-box policies. And that can be done with JavaScript, Java, or Python. And you can also host Node.js in here. Apigee Edge has a wonderful analytics system. You can use it to provide real-time visibility into the activity in the system. You can also use it to measure and grow your digital ecosystem. So you can look at operational metrics, but you can also look at business metrics. Apigee offers monetization, so if you decide you want to charge for access to your APIs, there's a monetization add-on that you can get for Apigee to do this. You can do revenue sharing models, fee-based models, or freemium models. Maybe the first 100 calls are free, and if you want something more than that, then you have to pay. Apigee Sense is another option. You can add Apigee Sense to do bot detection and detect malicious traffic. So you won't necessarily see this in the demo today, but Apigee has a collection of management APIs, and these let you control every aspect of the platform programmatically through a REST-based API. This can be used to automate operation of Apigee. Maybe you want to automate the creation of users or credentials for people. Or maybe you want to use this to push things into production automatically after running a series of tests. There's APIs to do all of that. There's a wonderful community and a bunch of resources to help you with Apigee. So there's community.apigee.com with over 10,000 users. We've got a series of 4-minute videos, one for each feature in the product. You can go in and learn about the spike arrest in 4 minutes, for example. There's a number of webcasts that are out there. You find those on YouTube. There's customer stories where we interview customers and they talk about what they do with Apigee. And we publish a bunch of ebooks. All of these are great resources to help you become productive with the platform. So let's look at a demo. What we're going to look at in the demo today is a simple set of APIs that sit on top of a set of weather data. The weather data is in BigQuery, and there's weather stations from all around the world. You can look those up by latitude and longitude, and for any given weather station, you can pull down historical weather. So this is what I've got. On the back, all the way on the right-hand side here, we've got weather data stored in BigQuery. In order to get at that data, I've got to log in using a service account in Google Cloud. And in order to get credentials for that, I have to talk to Cloud Identity and Access Management. So I'm going to send some credentials over there, and it's going to return to me an OAuth token. And with every request I make into the weather database, I've got to send that credential as a header. On the left-hand side of this, I didn't want to have that security. So what I'm doing instead is I'm using API keys. So I have a single-page web application. I've got a few mobile applications. Each of those has their own API key. So I'm splitting the security into two different parts here, the back-end security and the front-end security. There's some other things I'm going to do on here also. I want to build a facade on that back-end and hide away the details of where this data is. And I want to control access to some features. There's only limited things you can do in here. I want a rate limit to protect that back-end. I don't want people calling this too much. And I'm going to impose some quotas. So depending on which API product you're using, you'll have different quotas. And I'm going to add caching to help performance. I'm going to reformat the request as it comes in and the response when it comes back in order to make this more friendly to my developers that want to use this API. In the demo, we're going to consider three perspectives. The first one is the application developer API consumer. And that person might be saying, all I want to do is build an application. Make it easy for me to consume your services. We'll look at the API developer. They might be saying, I need to share a service with other people, but with some limits. And we'll look at the API team. And they might be saying, I want to think about APIs as software products. They're customers, life cycles, versions. I want to measure my program and tune it. As a developer, I might start here on the developer portal. From here, I can get what I need in order to be productive with these APIs and to start using them in my application. I see there's a number of API products and something that says Get Started on here. Let's look at the available API products. So I can see that there are a few APIs available. Let's look at this one. So here's some documentation on how these APIs work. I'm looking at the Weather Stations API. There's a URL in there, and it looks like I can put in a location, and I need an API key, and then it'll give me a list of weather stations. So I'd like to actually try this out. To do that, I'm going to go up and register a new application. We'll call it the Webcast Demo App. And we're going to go with this package. Now that's registered my application, and I've got an API key. Let's go back to the docs and give this a try. I'll put my API key in there, and we'll put it in location. I'm near Boulder, Colorado. Let's check the weather for there. And I see a list of weather stations that are near Boulder, Colorado. So what I like about this is I can try out the API right here, and I get an idea of what I need to send in and what will come back in the response. And that makes me pretty productive. I could start coding at this point. So I visited the developer portal. I read the documentation on how to use the API, and then I registered an application, and that returned a key for me. I took the key over to the documentation, and I was able to test it out in there. And I have a pretty good feel for what it's like to call the API now. So I can make a call in here and get data back. The next thing to do is let's write an application. So I've got a simple application that I've written here. And what this allows you to do is you can search for weather stations by typing in an address or landmark up here. And then you get back a list of weather stations, and you can check for high and low temperature data at that particular weather station. So I'm near Boulder, Colorado. Let's look and see what weather stations are around here. So I type in this location, and it's going to find me weather stations that are near that location. They get populated down here. So it looks like it's found a few. I'm going to go with this one, specify a year in here, and then I can run a query, and that's going to pull down the historical temperature data. So this is for the Boulder location, 2015, and we can see the high temperature data and the low temperature data in here. So not bad. This was pretty easy to write. It took me about an hour. Most of it was spent trying to format these graphs and to make them look nice. I added this little status button down here so we could see what was returned. I got a nice 200 there. If I run this a few times, let's see what happens. So I called too quickly, and I got shut down with some rate limiting. So that's our simple application. Let's switch roles to the API developer and see what we had to build in order to make this possible. So as the API developer, there's a few things I'm going to do. What I did when I was building this particular demo was, first thing I did was fire up Postman. And I called my backend service a few times and played around with it, read documentation, and figured out what it could do. And that influenced what I wanted to do in terms of building an API proxy for it. So once I decided on that and I was happy with how the backend service works, I came into here. And then I built a specification to describe my API. Let's look at that. So here's my weather history API spec. I've described how it works and the three different services you might call underneath there. One to look up weather stations, one to look up temperature data, and one to look up wind data. And I've specified all that in here. I can see what the documentation is going to look like. I've specified what the results look like. So this should give my developers a good idea of exactly how this works. So the next step is to build an API proxy. You might come to this screen under API proxies and hit this plus proxy button up here. So we have a few choices in here. Reverse proxy, the first one, is the most common. And this is where I started. You can use an open API spec if you have one, or you can just start with a URL and make a straight through connection and start to build up your proxy from there. There's a few other options in here. If I was working with a SOAP service, I might choose this second one. And that gives me an option to build either a straight through connection to an existing SOAP service, or to possibly build something that does SOAP to REST and REST to SOAP conversion. And that would, I'd supply the WSDL and it would build something for me. I might use no target if I wanted to mock this up. So what it does in that case is Apigee is going to return the response and it's not going to talk to a backend system. So I might mock up the response inside of this proxy and I could use that to provide sample data to my developers. Hosted target and Node.js allows me to host Node.js in here. And I might do that if I were going to orchestrate several backend systems, and I want the backend that's called by Apigee to be this Node.js code that then calls other services. And if someone sent me a proxy bundle that they've developed, I would use this last option to import it. So I entered my spec, and that created my API proxy for me and put me into the editor. So let's look at that. So let's look at the existing API. This is where I'll develop the API that outside consumers are going to use. Key things to notice here are target endpoints down there. And this is the backend URL that's going to be called. So instead of calling that directly, my consumers will now call one of these URLs up here. That talks to Apigee, and then Apigee sends the request to the backend. We also have, you'll notice there's two different URLs here. I have a few different environments I can deploy into. In my demo environment here, I have a test and a production environment that's available to me. And I have version 7 in production and version 8 in test. So they'll call those URLs to talk to the backend system. It'll be managed by Apigee, and traffic will flow back and forth. So let's dig in a little further and see what's over in Develop. So we're over here on the Develop tab. And what we'll notice in here is there's a few different sections to this screen. Let me go through those, and then I'll go into some details. So up here, we have a graphical depiction of the request and the response flow. So the request comes in, goes to the backend target, and then the response comes back. And along the way, we can have some of these policies in place that are going to help manage this request and response flow. Those policies are configured down here at the bottom. So I'll click on one of these, and you can see how it's configured at the bottom. Policies that I've used in here are listed over here. I can reuse these. I can drag and drop them over here. Things for the request go on the top. Things for the response go on the bottom. We have two sections down here, proxy endpoints and target endpoints. Proxy endpoints control what happens between the client and Apigee, and target endpoints control what happens between Apigee and the back end. So for proxy endpoints, there's a few different flows in here. The pre-flow is executed unconditionally at the beginning. So people might put different things on the end of the URL. They might call this in different ways with a post or a put or a get or something like that. We may want to have the system behave differently depending on how they're calling it. So pre-flow is always called first unconditionally. I tend to put things in here like checking for security tokens and rate limiting and things like that. The next few that I've got in here are conditional. So I can click in here and I can add a new one. And I can choose a path and a verb and some sort of condition. So those are called conditionally. So if somebody calls my URL with /stations at the end, that gets called if they call that with a HTTP GET. Same thing for temperature and wind. And then post-flow is called unconditionally at the end after the others execute. So first pre-flow, anything conditional, and then post-flow. The same conditions hold true for the target backends. In my case, I've only got one backend and I don't have any specific logic in there. But let's imagine we had a bunch of different backend systems and we might be doing some dynamic routing among them. We can have different conditions in here for those different endpoints. Down here, I've got some resources. So these are JavaScript files in this case. So things like code and files that are associated with this API proxy go down here. And I've got JavaScript policies that reference some source code, and that's the source code right there. So let's look a little bit in more detail in here. So we have a few policies in place up here. Where did they come from? I came over to here and I hit the plus step button. And inside of here, I'm greeted with a menu of possible policies that I could put in there. There's a few things around traffic management. There's some around security, some around mediation, and then some extensions. So let's look at each section here. Traffic management is going to do basic traffic management things. So quota. Quota would limit how many times you can call something in a certain period of time. So maybe I want to limit this to 100 calls per day. Spike arrest is going to limit how it's called, but based on frequency. So think of this like a circuit breaker. You don't want somebody to call this too fast. I might set this to 100 transactions per second, and if they call at a rate greater than that, it'll return an error. We have several policies for caching, so basic response cache, and the ability to manipulate these different caches programmatically. So you can have named caches, multiple caches. They can have different times to live, and you can use them at different points in your flows. For security, we've got a number of options in here. Basic auth is going to request a username and password from somebody who's calling the system, or it can be used to construct a header to send to a backend system that expects that. The next three policies are there to make sure that bad things don't get through in the request. We have a full implementation of OAuth 2. We can check OAuth tokens. We can generate OAuth tokens. For backwards compatibility, there's some OAuth 1.0 in here. We have the ability to verify API keys. Access control would let us limit calls to a certain range of IP addresses. We can blacklist or whitelist certain IP ranges. If we need to generate or validate SAML, we have SAML assertions in here, and we can work with JWTs. Under mediation, we have policies for JSON to XML, XML to JSON. We can raise custom error messages, check monetization limits. We can do XSLT and SOAP message validation. Assign message and extract variables I use a lot. Assign message lets me change the request or the response in some way. So let's say I want to insert a header, or I want to take something out of a URL and put it into the body. I'd use that with assign message. Extract variables lets me grab something out of that request or response and use it as a variable inside of Apigee. Access entity lets us load up metadata, and key value operations lets us work with the key value map. It's a very nice key value map inside of Apigee Edge that lets you store anything that you need at different scopes. So for example, in here, I store an API key that I need to talk to Google Maps. And I'll use the key value map, pull that out of there, stick it into a request, and make my call. So those are the basic policies that do things that are very common. We also have some extensions in here. So if you want to do things in programming languages, we have Java, Python, and JavaScript are supported. With those languages, you have complete control over the request and the response. There's variables in there to be able to grab things like headers and stuff like that, or the body content. You can change it around and replace it. We'll see an example of that in my demo. Service callout lets me do an HTTP callout before I call the back end. So for example, in my demo, I use that. When I type in the location of a city, it makes a call out to Google Maps and it returns a latitude and longitude. I then send that to the back end. Flow callout lets me execute a shared flow. So let's say I've got a flow that I want to use in many of these different API proxies. I could build a shared flow for that, and I access it with a flow callout. That lets me reuse code. The statistics collector will allow me to store a variable in the analytics system. So if I want to build a custom report, I can grab data from this custom variable, and I can show a custom report with that. I can log something to a logging system. Maybe if this rate limit is hit too often, I might log that. And then there's a number of extensions that we can use that make our back-end systems easier to work with. So that's the basic policies that are available to you. Let's look at a few of the policies I used. First thing I'm going to do in here is check for an API key. And I'm looking for an API key as a query parameter. If I don't get one, this is going to return an unauthorized error. I'm rate limiting. I'm limiting somebody to 10 calls per minute in here. If they call faster than that, we'll return an error. I'm checking a quota. The quota is based off of an API product, so we can have different quotas for different people calling this. We've got a response cache in there, so if I already have the answer to this, if somebody sends me the same request in a row, I'm going to grab that from memory. And there's my shared flow that's going to log me into Google Cloud. So that's a few things I do with every call that comes in. This flow is where I look up weather stations. So someone specified a particular location, an airport or a city or something like that, and I want to find weather stations that are near there. So the first thing I do is I'm going to make a call out to Google Maps, but I need something before that. I need my API key that gets me into Google Maps. So I'm looking that up from the key value map. From there, I'm going to construct a request, and I'm going to send that address or location into Google Maps. I'm going to ask it what's the latitude and longitude. And I need to pass along an API key to identify me. And then I'll call this URL down here. That's going to respond back with a description of the location. And that has a lot of information in there. There's two pieces of information that I'm really interested in. Really the only thing I want out of there is the latitude and longitude of that particular location. So that is buried in a certain section that's under geometry.location. And then underneath there are latitude and longitude. So I've got a JSON path in here to show where those variables are. And then I'm going to store the values of those in lat and lon. Next, I'll construct a bounding box around that particular location. So what this JavaScript code is going to do is create 4 variables down there. A minimum longitude, a minimum latitude, a maximum longitude, and a maximum latitude. And those are stored as variables that I can then access later in the flow. So that's what all this code does. And then next, I'll construct the query in here. So I've taken all of this information that I've gathered, and I've used that to build this query up. Now, when somebody called this, they just sent a location, and it didn't have anything to do with databases or any kind of query language or anything like that. So I'm taking the request that was sent in that contained that address. I've gone and looked it up and calculated some latitudes and longitudes, and I've built this query, and that's what I'm going to send to the back end. So that goes to the back end. I've completely replaced the payload in here with this. That goes to the back end. And then we'll get a response. And then down here, I reformat the response so that it looks a little bit nicer. So I'm really just taking the code that comes back and reformatting it to make it a little bit nicer, and I'm sorting it by distance. So that's the basic flow. If we go into a little more detail here, we want to look up once somebody has a weather station and they make a request, what does that look like? So they make a call in with /temperature, and they're going to supply a few things on the URL. I need to grab that data off of the URL, and then I'm going to go and find the data for that particular weather station and that year. So this first policy here is going to grab the variables that I need from the URL. So they're calling /stations. They've supplied a weather station ID right there. Then it's followed by years, and then a particular year is supplied there. So I want to grab these two pieces of information and store them as variables. And then my next step in here is to build a query for this. And I'm going to send that into BigQuery, and it's going to return a big set of data for me. And again, I've replaced the request with a different one. This is a statistics collector, and it's going to save the weather station ID in case I want to run a report on traffic by weather station ID to see which weather stations are popular. So that's how I built my API proxy. This is a bit more complicated than what most people would build. Most people are going to take a backend service, and they might just be collecting a security token and then sending the response back, without any modification. And that's a great place to start. I wanted to show this to you because it shows all the different things you could do with Apigee if you wanted to. Much simpler things can be done, and that's a lot easier. So when I was building this, it didn't quite work at first. I had the request in the wrong format, and when I sent it to BigQuery on the back end, it returned an error. And what I realized was something in my request was a little bit off. So I ran over to the trace tool over here, and this helped me debug. Let's start a trace session and see how this works. So I'm going to click on the button there to start up my trace session. And then I'm going to go out to my client application and send in a few requests. Let's go back to something that's not cached and see how that looks. So we'll see requests start to come streaming through in here. I'll run a few of these so we have a variety of results. So here we see a call entering, and this one is for temperature data for 2014 for this particular weather station. And there's our API key on the end of that. So we see this coming in. We see the request content. Let's look at the steps and see how it got that way. So there's the API key check. What we're seeing in here is a whole bunch of information about this. So when the API key is evaluated by Apigee, it loads up a ton of metadata. And you can use these, all these become variables in here, and they can be used throughout your flow for different things. Maybe you want to dynamically route somebody to a different server based on some sort of metadata that's associated with this key. We'll see the spike arrest and the quota policy being checked. It's looking to see if we have the cache. There's a false there to say it wasn't found in cache. And then this is my shared flow that authorizes me with BigQuery. We'll see the variables being extracted, and then the final request is sent in. And we can see that this looks very different. So we saw it came in as a get here, and then it went out like this. So we're seeing it turned into a post. So there's the post, and that's what's going out to the back end. We see the response coming back. So we can see the format of the data that's returned from BigQuery. So we can see that I changed that around a little bit, made it a little bit cleaner and easier for the developer to understand. So that's a basic flow in here. This second one we'll notice is a bit shorter, and that's because we're hitting cache. So the response is being returned straight from cache. And it's a lot faster too. Here's our rate limiting. So in this case, Apigee Edge detected that this is being called too quickly, and it shut it down. So I've got this spike arrest right here. That was tripped. And then we'll see that a custom error message is sent back, and it says call rate exceeded. This application is limited to 10 requests per minute. And that would give our developer a pretty good hint about what's going on, so you have a good idea of exactly what went wrong. Now, when I was building this API proxy, I found out that I had something a little bit wrong in that query. So I had gotten a quote in the wrong place, and so BigQuery was rejecting it. And I saw that in the trace tool. When I looked at the payload, I could see that the mistake was in there. I went back and fixed it. So this is really helpful for me. It helped me find that mistake in a big hurry, and I was able to fix it. So that's how we would debug and trace something. The next thing to think about is publishing. How do we take this and publish it out so that somebody can use it? So I want to talk about the concept of API products, and this will become important when we start to think about how to publish our APIs out for consumption. So we use API products in Apigee Edge to share your APIs with consumers. And let's think about this for a minute. We're not just thinking about services anymore. These are now becoming products. And so there's a whole life cycle of these APIs that people want to consume. We've got to think about how we might manage that. So we're going to take a formal approach to this, and we're going to think of these as products. And a product might contain more than one service. So what that looks like inside of Apigee Edge is we've got those API proxies over there on the left, and that's what you saw me walking through here. I've got this particular weather API. And I can have a number of products that give access to that. So I have silver access, gold access, and platinum access as an example here. And they give you different entitlements, and those are different metadata that's associated with those products. So silver gives us 100 calls per day with 5 calls per minute and some limited access. We can only do some things. So for example, I might only be able to look up weather stations, but I can't get temperature or wind data. And gold access might entitle me to more calls, and it would give me full access to all those different things that are in the APIs. So I have a series of these products, but people don't have access yet. If I want to grant somebody access to call this API, I'm going to register an application. So let's say we're building the Android application for looking at weather history. I'd register my application and some metadata associated with that, and that would generate some keys for me that I could use to call into the system. So you register an application, and that gives you access to one or more products, and those products have entitlements to use certain APIs. So we don't just have a service and everybody calls it and we don't know who's who. We're going to have a system in here for managing products, and we give people access to these products. They have API keys, or they're going to be sending OAuth tokens or JWTs, and that lets us track exactly who's calling things. So where do we get these keys? We create an API product inside of Apigee. We can decide which proxies are going to go in there and which resources of those. From there, we register a developer application. And a developer can have access to more than one API product. And that generates 2 keys, a consumer key and a consumer secret key. And you use the consumer key as your API key, or you're going to use both keys if you're going to generate an OAuth token. So that's a quick overview of API products. Let's go back and see how we do that inside of Apigee. So let's click over here on the box, and we'll see that in this section we've got something called API products. And I'll show you an API product that I built for my weather demo. So we have the weather history try it out down here. Let me put this in edit mode so you can see what it was like when I created it. So I called this weather history try it, and it provides 100 calls per day for development usage. And the access is public, meaning it'll show up on my portal. I've got 100 requests for every 1 day, and that's the quota. This describes what's available in my API, so anybody who calls that URL, I could specify in here something a little more detailed, like /temperature or /stations if I wanted to. And then we can see down here all the different developer apps that make use of this product. So let's look at the webcast demo app. So here's our application. We can see that its usage was approved, and we have a key and a secret that we can use for calling this. If I wanted to add custom attributes, I can do so down here. I might have partner ID on there or something like that that's meaningful to my business. And whenever this API key comes through here, that variable will be loaded up and I can use it for logging or for traffic redirection or figuring out how to limit them or whatever I want to do with it. So this is one way to create an application and register it. You can do it by hand in here, and I can register this for a particular developer. I send these credentials to the developer and they're good to go. But another way to do that, probably a more common way to do that, is that the developer would do this, and they're going to do that using a developer portal. So our third perspective is the API team. Let's look at how they would use Apigee to manage their API program. The API team has an interest in knowing how things are running, so they may come into the Analyze tab over here and look at some of these reports. The first one we'll look at here is proxy performance, and this is just going to show us the very basics. So how much traffic did we get? What was the average response time? What's the traffic by proxy? And what's the average response time by proxy? So quick high-level summary of what's going on. I can change the dimension up here from hour to day to week or some custom time period. Another report that might be interesting is developer engagement. So who is writing applications? So we've got 10 total developers that are registered, 7 have registered applications, and 4 are highly active, or 4 are active, and 2 are highly active. This gives us an idea of who's using the system and who's going to be using it in the future. The devices report is going to show us what kind of devices people are using. So who's on which type of browser? Are they on a mobile device? Are they on a desktop? Are they running Chrome? Are they running Firefox? Maybe there's a few folks that are still on Internet Explorer. We can see all that on this report. And that might help us guide where we spend our development in terms of applications. The map shows us where our traffic's coming from. So we've got traffic coming from the United States here and some calls from Canada. If we click through, we'll see that Colorado's highlighting. That's where I am, and that's where I'm sending my request from. Target performance is going to show us how the backend system is keeping up. So this gives us an idea over time of what the response time is for the backend system. And traffic composition will show us our top 10 proxies, top 10 apps, top 10 products, and give us an idea of what's most popular at this time. And there's a bunch more reports in here that you can look at that do different things. You can also build custom reports, and you can grab anything you want out of the request or the response and build a full-featured custom report that gives you exactly what you want to see. Finally, our API team might also be interested in monitoring, so they might come over to the monitoring dashboard. And this is where we could set alerts. If we want to configure some alerts and some notifications when things happen in the system, we can do that in here. This is a whole other topic that's worth digging into, but we're going to cut short on this for interest of time. So we looked at the demo from 3 different perspectives. We looked at how the application developer or API consumer was able to easily go out to a portal, learn everything that was required, get credentials, and start building an application and sending in traffic very quickly. The amount of friction required to build that first app is very low. We saw how the API developer took an existing service and started to manage it with Apigee and put some products in place so it was easy for these developers to consume it. And finally, we saw how the API team would look at some analytics dashboards and monitor how their program is going and use the monitoring features to make sure everything's running smoothly. So let's take some questions. So first question in here is, how do you do versioning in Apigee? So good question. I get this a lot. So there's quite a bit of religion around versioning. What I typically recommend to people is that you've got a URL, and that URL is going to have the version number in it. So put a V1 or a V2 in your URL as far to the left as you possibly can. So what you do in Apigee is you can take your proxy and you can save it as a new revision. And then inside of there, you just change the URL that it's listening on. So you might have V1 weather demo, for example, or V2 weather demo. And then you're free to change that around as needed. So that's versioning. There's also the concept of revisioning. So Apigee has a built-in revisioning system. You might have noticed in the demo that I was on like revision 7 and 8 in there. The way that works is that's going to allow you to roll back to previous versions of your API proxy. And in some cases, you might make changes in there that I would consider a revision, but not a version. So I would consider a version something that breaks the contract with the client. And if you change around the payload that's sent back in such a way that it would break the client, then that needs to be a new version with a new URL. If you're just adding caching or fixing the way that your proxy works, but that doesn't necessarily change the data that goes back and forth, that's just a revision. So those two things together kind of make up revisioning and versioning. Will Apigee export a proxy to Open API format as well as import it that way? You can definitely import one that way. So you can, there's a whole spec editor inside of Apigee, and you can edit your specs in there and you can publish them out to the portal that way. We do have some tools out on GitHub that'll introspect an existing API proxy and make an attempt to generate an open API spec. If you work with a WSDL and you're doing a SOAP service, that part of the SOAP wizard there will automatically generate one for you. What about role-based access control? How do we keep people from seeing stuff they shouldn't see? Good question. As I went through this, I'm the administrator, and yeah, I can see all kinds of stuff in there and I can push to production. A typical way of doing this is there's a role-based access system in there, and we would use that to control what people have access to. So I might have access to a staging place or a QA environment, but I don't have access to production. And we might use service APIs in order to push things into production. So we might use the UI for some of our development work, but then we're going to check the source code into Git. We're going to pull down from there, maybe run some tests on it, and then we'll have that automatically pushed into production. Is it possible to combine the results from more than one backend, build an aggregate or a composite? It is. So go out on YouTube and search for Apigee Up Close, and you'll find I did a whole webcast on that topic. So just in summary, what you do is you can call out to 2 or 3 backend services, and then typically you would use one of the programming languages, Java, JavaScript, or Python, and build a composite result in there to send back. But yeah, we've got a whole webcast on that. Is Apigee only for people that have external API programs? Do people use it for internal API programs? They do. So yeah, oddly enough, most people are using it for internal API programs. We have a small subset of people who have external facing APIs, and it's fantastic for that. But the same kind of benefits you might get when you're running an external API program, those could be used inside your company for people that are external to your group. So same concept, but used internally. Does Apigee support Open API Spec version 3? Yes, it does. So yeah, you can try that out in the spec editor. Can Apigee return a different response based on an accept header, for example, JSON or XML? Yes, that's something we see pretty commonly. So let's say you have an existing SOAP service and you want to have that return either XML or JSON, depending on how somebody calls it. So you can put a condition in there, and that condition would be used to determine whether it runs the XML to JSON policy, and that would return it. It would behave differently depending on how you call it, which header you send in. So nice way and very easy to build an intelligent API like that that's going to respond with what people need. Can you use Apigee to control access to a cloud function? You certainly can. So it's a common use case for that. You might have a service account enabled for your cloud function, and then you'd put Apigee in front of it, and only Apigee would be able to access that with credentials. And then you might manage the security to the outside world with OAuth tokens that are managed by Apigee. Can you export analytics data using an API? Yes, there's a whole API in there for getting an analytics data. Check the Apigee documentation, and within there you'll see that there's an API. You can specify a time range, and you can pull down analytics data programmatically. Let's say the backend changes. Can you pre-populate or invalidate that cache that you're using in there? So yes, you can. There's policies to adjust the cache programmatically. You could also run that through the UI. There's a tool in there to flush the cache, and you can do it through a service API where you call the cache directly, and you could pre-populate it or you could flush it if the backend has changed. Can you route traffic to different backend servers based on something you know about the identity of the calling application? So for example, partner A and partner B both call the same URL, but they should be routed to different backend servers. Sure. So what is typically done in there is when you generate an API key or an OAuth token, you can apply custom metadata to that. So you would put in there something that lets you know which partner this is, or gives an idea of some sort of identity that you can use. That becomes a variable when their call comes in. So as soon as it processes the OAuth token or the API key, that data is loaded as a variable. And then you have a condition in there, and you can supply multiple backend targets inside of Apigee, and you can set up a route rule. So that's all built in to do that. You would look at that attribute and then route to A or B based on that. Is it possible to have different quotas for the same API? So for example, person A and person B both call the same URL, but are limited in different ways. It is. So oftentimes we'd put a quota on the API product. And then when you go to generate a key, you would either choose one product or the other, depending on what you want that quota to be. So when those two people call that API using different API keys, they'd be rate limited differently. What are the key features of an API gateway? So I made a point in here of distinguishing between a gateway and an API management platform. A gateway tends to be more security focused. So this is the gateway that we're going to use to let people in, and it's going to check OAuth tokens and send them along if they have one and block them if they don't. So a gateway tends to be more around that, more networking based. And then an API management platform is considering all these people. So it expands on the gateway with the ability to manage developers, to manage keys, to have analytics and things like that. So that's a much bigger solution than a simple gateway. Sometimes a gateway is appropriate for what you're doing, and sometimes you need a full API management solution. So question in here about what is the use of custom attributes in products? Can you share an example where that's useful? So yeah, that goes back to the other question. When I created an API product, I might put a key on there, and that's going to be propagated to all the apps that are generated. So basically, that attribute will go on to any keys that are generated for apps, and then it comes through as a variable. And you might use that for conditional expressions. So you might have a policy that either executes or doesn't based on that, or you may have routing rules based on that to send them to different places, or the quota might be enforced based on that. I think that's about all we've got for time today, so we're going to go ahead and wrap it up. Thank you so much for attending today. We appreciate it. We'll see you in the next webcast.